Good morning and most welcome to Heidegger 1423. Today is the aftermath after the interview with Stephen M. Rosen. Still a little bit shaked up. It was a very interesting and grand meeting to have an hour with this fantastic gentleman of both graceful and very sharp. We were discussing his topological models, so immensely helpful for the understanding of quantum mechanics, Heidegger, Merleau-Ponty. Idea brings connectedness to a reality that mostly is disjunct and fragmented. So we continue that lead, that force that started yesterday, and go on where I left off in 1419, page 104, and it's rather to the end of the second paragraph. And we've been discussing lineland, or the one-dimensional life world. Do you remember that depth is, according to Merleau-Ponty, the foundation for all dimensionality? It all starts with depth. If the Kleinian structure constitutes the dialectical circulation of subject and object, by which the three-dimensional life world is completed in earnest, and if the self-intersecting Möbius structure is the subject-object vortical spin cycle that completes the two-dimensional life world. Then the self-intersecting Lemninsgate would be the dialectical action that would bring to fruition the one-dimensional life world. Still, with each step down to lower dimensionality, the dialectical tension of dimensional spin would be less. the perspectivity weaker, that is the opposition and integration of the perspectives of objects and of subject and object themselves, would be less sharply defined. The relative weakness of dialectical opposition in the lemniscatory life world is indicated by the fact that here only one element of differentiation would be operative, that of the point. The last member of the bisection series is the sublemniscate. In three-dimensional space, this structure appears as the interlocking lemniscatory surfaces illustrated in figure 5.4. How would the sublemniscate be manifested in the two-dimensional environment? Table 5.1. Illustrate the general idea that in moving into lower dimensional life worlds, lower order members of the bisection series assume the rules of their higher order counterparts. Therefore, in two-dimensional life world, just as the Möbius structure will play the Klein-Bottle's role, and as the lemniscate would play the role the Möbius plate in the three-dimensional space. It would be an open, integrative circulation. It would be an open cycle of dual character, a two-edged line, with each edge tracing a lemniscatory pattern, eternity, or the eternity symbol/token. Continuing the reduction, the sublemniscate of the one-dimensional life world evidently would operate as an open integrative point, thereby assuming the role that was played by the lemniscatory line in the two-dimensional life world. Then, in the zero-dimensional realm, the sublemniscate would finally come into its own. Dialecticity would be completely absent in the zero-dimensional sphere. This is borne out by a clear-cut difference between the zero-dimensional situation and those of higher dimensions. The three orders of life world dialecticity are expressible in terms of the dimensional interplay of container, contain, and uncontained. Here you can see that what is stasis and movement are two aspects of the very same thing. Stasis does not exclude movement, and movement does not exclude stasis. This excludedness is the spectre of the Western thinking, and it is suffused in our perception and language. The Möbius line and the lemniscatory point and the surface of the lemniscatory surface are all pointing to this connection between stasis and movement. And it is one of the most important things to consider. That was specifically pressed by Stephen M. Rosen yesterday in the interview. And this is also a dichotomy hardly ever mentioned in any strand of philosophy. Of course, a good example that I mentioned many times before is the paradox of Zeno, but there are many others. I think the liar paradox goes into this as well, because there is a movement in the tension in between falsity and truth. And here he introduces more properly the zero-dimensional realm. I will have to take some tea for that. Or maybe coffee. Coffee with cardamom to make my palate wake up. To begin to appreciate the uniqueness of zero-dimensionality, let us for the moment regard higher dimensional containment relations in the simplified conventional terms, rather than concerning ourselves with the paradoxical self-containment that underlies them. we can say then that at each level the containment of objects is enacted by the lower dimensional bounding elements of the containing space. The planes bounding three-dimensional space, the lines bounding two-dimensional space, and the points bounding one-dimensional space. These relations suggest the general idea that the nth dimensional bounding element of the n-dimensional space itself serves as the containing space in the relation to a lower dimensional bounding element. For example, the two-dimensional plane that bounds objects in three-dimensional space would function as space itself in the lower dimensional life world, wherein the highest dimensional bounding element is the line. What we encounter in making the transition to the zero-dimensional realms is the complete absence of bounding elements, and thus the absence of space, for there can be no spatial container if nothing can be contained. I'll say that it's to the kernel of the reason here, it's very important. There can be no spatial container if nothing can be contained. So there is a complementarity between container and contained that is almost always ignored. the zero-dimensional point that bounds or differentiates one-dimensional space does not translate as a spatial container possessing its own lower dimensional bounding element, because there is no dimensional element below zero. This is reflected in the fact that, unlike the plane or the line, the point is utterly indivisible. It cannot be partitioned or subdivided in any way. It is clear that, given the absence of bounding elements in the zero-dimensional sphere, the dialectic of spatial container and objects contained cannot be enacted there. There is, of course, listen now, a third term of the dialectic inseparable from the other two, the uncontained, the subject. Obviously, if there is no spatial container and no contained object, neither could there be the detached vantage point of reflection upon the object that constitutes the subject. Since the zero-dimensional situation would be characterized by a complete lack of containment, there could be no self-containment here either, no life-world dialectic. It is this total absence of dialectical structure that require us to leave blank the zero-dimensional row of table 5.1. So for there to be containment, that needs to be a container. But containment doesn't mean anything without container. The same goes for the uncontained, the subject. It is participatory, and I clearly understood that with the cube, that the hidden edges and sides, that is the subject, the uncontained. The detached vantage point is also a very intimate. It's inside the object. It is what constructs the object. Rosen is here pointing to something that is absolutely crucial. Not only that space around objects are necessary for the objects to come into existence, but space wouldn't mean anything without the objects. But there also need to be something uncontained, detached, and that, my friends, that is the subject. Participating in what makes up the lemniscatory movement, which we are entering here now. 5.2. Topodimensional spin matrix. Now Musée indicated a higher epsilon algebra, wherein the root of epsilon involves the in, the subscripts of course referring to the n+1 dimension. Since I equals I already refers to D2. Bearing in mind the intimate relationship between the Klein bottle and epsilon, we may adapt Musée's implication of a dimensional hierarchy of hypernumber values so as to express our geometric bisection series via algebraic notation. The three-dimensional Kleinian spinner can be written epsilon D3 with lower dimensional members of the tightly knit spin family designated E2, E1 and E0. The relationships among these values are given in table 5.2. The topodimensional spin matrix in the matrix representations, a square matrix like that given in table 5.2 possesses a principle or main diagonal. The one extending from the upper left-hand corner to the lower right. It is here that the eigenvalues of our topper-dimensional array are displayed. My comment here, you might recognize eigenvalue that plays an important role in quantum mechanics. The word eigenvalue is a linguistic hybrid containing the German word eigen, meaning own. Eigenvalue is a reflexive term indicating the primary elements or essential properties inherent in and unique to a given matrix. The own values or self-values of the matrix. The eigenvalues of a matrix have been alternatively expressed as the values that are characteristic of or proper to the matrix. In Heinz von Förster's system theoretic application, according to the following, he said, eigenvalues, because of their self-defining or self-generative nature, imply topological closure, circularity. I would say here we have individuality stemming into action. They have their own individual character, unique to themselves, an independent existence. And this is one of these other dichotomies that is indirectly approached here, and that idea that individuality excludes relationality. It does not. Rather, relationality enforces individuality. That, of course, goes against the very fiber of Western dialectical thinking, where it's either the individual or it is the relations, the mass, the whole. Do you have probably a bleach pen? We just finished that sentence off. An eigenvalue characterizes the self-referential spatio-subobjective action of a whole life world. The four eigenvalues of our topodimensional matrix thus corresponds to our four basic orders of topological depth, whose interrelationships are specified two at a time in table 5.2 by the matrix elements appearing off the principal diagonal. This is definitely one of those things that is almost as problematic for the Western dichotomy thinking. I mentioned the difference between stasis and movement, that they are the same. And here we have the eigenvalue, the individuality, in contrast to relational. And both those things, as we know, are present, and they enforce each other's. The individuality becomes stronger because of its relations it has. It is similar to the Leibnizian monads. The monads, you might remember, lack windows. They get their individuality from relations. And they are pure individuality at the same time as they are pure relational entities. They are the most individual that can be, but still they lack windows. Why is that? Well, they are not individual in a universal, generalized way. They are even more individualized. The eigenvalue is only one. It is absolutely 100% unique. And we lack words for that. And once again here, Stephen Rosen with his images come to the rescue. This most difficult problem. But it does defy normal thinking. How can you even figure out an individuality so strong, so iconoclastic, so unique, that it is literally only one for eternity? And it is this very individuality that is accomplice to making up both the containing space and what is contained. And the uncontained absolute individuality and absolutely relational. And that is, of course, very odd for us even to ponder for a second. And I would say the Leibnizian model doesn't go the whole way. You do not realize the uniqueness of the monads in his metaphor. But now it comes clearer to my thinking. An absolute uniqueness that defies what we regularly think of individuality. There can be only one. In a way, it's bordering to solipsism. And that's another dichotomy that often says stop to us. Don't go into that alley. There you have to choose between solipsism or absolute materialism. Our thinking does not allow both. And I would say we can't even understand both. But here, slowly, understanding is coming to fore. That it's even a necessity that both are present. Can all the values of an individual monad, atom, or a person be reduced to its relations? Absolutely yes. But that still is not enough. There is how complementarity works. The dual character of the universe shows that individuality can also explain everything. Put a little pause here and do something for that. So welcome back to the summary section. And here I depicted a table 5.1. Rosen mentioned yesterday that it is usually perceived as being very difficult, but we've gone through some of these parts. Speaking of surfaces, points and lines, and how we go over the surface of the Möbius strip and thereby covering the whole Möbius strip. And that is open integrative. It brings in everything. But it can also be closed depending on what dimension that we are currently in. This is a chartered way of getting away from the demanding dichotomy of the line, the square, and the cube. I mentioned that last. If you don't have this, you by default will go to the line and the square and the cube and so forth. Stephen also mentioned the hypercube yesterday. And then you go on to all the dimensions. Here you can see that depth more than the dishevelled or naked Pythagorean geometrical stops, I would say. It stops thinking, it stops existence. These are not interpenetrating. The subject is not present, or rather the presence of the subject is by the Pythagorean line, square and cube defied. It's a way of trying to stop the tendency of the subject, evicting the subject from what is presencing, and thereby leading to dichotomies. It is accomplice in this movement. Then you get this still world with stasis being one thing, and in a Newtonian scheme he had to make do with that movement was utterly different from stasis. And he developed his timeline as a substitute. And of course, in Newton, time disappears. Here it's shown that these are cycles. They are movement themselves. Objects are not one thing, and movement is not another thing. Objects are movement. And this is, of course, not a common thing to say, but it plays out really well with quantum mechanics. That is actually the view of quantum mechanics. In quantum mechanics, from a Newtonian perspective, position and momentum cannot be defined simultaneously. And that goes to show you cannot separate the two things. There is no separation possible. It actually shows, although everything can be accounted for to a certain extent by the Newtonian paradigm, everything can be accounted for. It would look as if we live in a complete world where everything is explained. The problem doesn't lie in whether the explanations are true or not. The problem lies that that system cannot be both consistent and coherent. And that's another thing than false. Rosen shows that that misconception is graver than being false. And of course, we haven't proven Newtonian paradigm to be wrong. It still works, it's still true, but something worse is lurking behind. And that is this misconception or random simplification. We discussed yesterday that this possibly could have developed in antiquity. And I think it's a tendency from the start, and slowly it goes more and more into our systems. And as it does so, it becomes foundational. It builds these dichotomies, and the dichotomies are not an extra thing. The dichotomies are what builds the antiquity Newtonian system. the very idea that exclusiveness or excludedness is there, that is actually before physics. So I think there is a good point to what he said yesterday. It needs to be before even physics. Well established before even the first philosopher of nature on the Ionian coast made his first thinking. Yeah, of course, in a germinate way, it was still a seed. But this seed is dichotomy. It is part and parcel. Here, it's includedness. Yes, I know it looks complicated, and as I said earlier, we discussed this. It has to do from where we start. This is actually a much simpler system than the one we already have. But it took us generations, millennia, to have the Newtonian paradigm well established. So we can do it without thinking. It is in our veins, it is in our muscular system. When we talked about that, I came to think about constructive mathematics, which is more or less the true variety of mathematics. But you need to take away the habit of the law of the excluded middle. And that is proven to be almost impossible to do for a mathematician. That intuition is well established before that person even enters the career to start out as a mathematician. And for every time you train the intuition, it becomes stronger. So it is a work, and this is not as forbiddingly complex as it looks. It is actually a much simpler way, where the subject is always interpenetrating the other side. The thing that is contained and what contains it. It is a participatory game, and it is a movement shown by Rosen as the lemniscatory movement, which fittingly is also the symbol for eternity. So you have eternity, and you have momentarily, and they are not that different. They are actually not contradictions. Something can be momentarily as it is eternal. The lemniscatory surface and the lemniscatory line and the lemniscatory point all shows that, all show to the same thing. The inherent movement between the uncontained, that is, the subject, thing contained, and what contains it. It's a co-working situation. And it's, for my take, the best, clearest explanation of quantum mechanical discovery in the 1920s. Specifically what happened at Palais de Solvay in Brussels in 1927, where the dual character, the yin and yang symbol of Niels Bohr, that they are together, not excluding each other, but not making everything general either. That is a tendency from this. Everything becomes general, even what we would call general. Maybe general is something particular, specific. This gives me associations to the left hemisphere when I speak about Newton. It is most definitely not going into reality. It is representing. The subject makes itself disappear, or the starting point is to get rid of the subject by establishing dichotomies. And in the end, I become a pure inside and the world a pure outside. And as I mentioned before, in patients with the right hemisphere lesions, stroke and so forth, the world becomes flattened out without depth. This very depth is the depth that Merleau-Ponty is mentioning. This is the depth of true dimensionality. And it's the first dimension before anything else. So what this does is to show that from the true depth, all the other dimensions stem. It is like the Lemminskate and zero are accomplices. They are together on this. Zero is very important. And this, oddly enough, this must be synchronicity. Is something you mentioned several years before when we spoke about the lemniscatory and the zero. That was ages ago. An odd coincidence. And that came from a completely different direction. So you see here, eternity and moment in the same. Maybe there's some question to Kalle.
Put it here.
Thank you. Please let me repeat one phrase from Rosen, page 106. There is, of course, a third term of the dialectic inseparable from the other two, the uncontained, the subject, the uncontained, the subject. So let me see how I could interpret this phrase. So let's say you have surface. Okay, this was a good pen. Surface. we could say like this whiteboard is the surface, and then let's say we have depth, we have like depth here. And in this case, the uncontained would be myself, the subject, because you need the third thing, otherwise this would not exist. This, I suppose, is one way of explaining it. Then soon you will ask you to correct me. And I was thinking of Carl Rovelis' relational quantum physics in Helgoland. He says, this is his words, he says that entanglement is not a dance for two, but a dance for three. That is, he compares with two electrons. He says that you need a third person. Why do you need a third person? You need a third person because this person checks if these two are related, if these two are entangled, and how. So if one is red, the other one will be red too. So you need a third person in the entanglement in Carl Rovelis' relational quantum physics. And this is a good parallel to this very phrase in Rosen, page 106, which I will repeat, is so important. A third term of the dialect inseparable from the other two, the uncontained, the subject. But I would like that you, Hans, explain this more from a topological viewpoint. You have elaborated it, but I think it still needs. Could you say like that, surface test or something like that, or how would you oversimplify it?
Yeah, it's interesting. I didn't know that. I did read the introduction to Helgoland. Yes, this is exactly what it's about. Yes. And the uncontained is the observer. The contained things are the electrons. The containing is the distance. What keeps them distanced? That is in the triad here. All these things are incredibly important to make up what the relation is, what the entanglement is, where it is. So you see, space is also an accomplice here. Space gives a gift of distance. It can also give the gift of momentum, but it needs space. There cannot be distance without space. And this is also what you can see in the Klein bottle. The very idea of space without objects doesn't really hold in Newtonian perspective of a homogeneous, as you said, Kalle here, homogeneous, almost intently pointing to the Newtonian canvas. But here goes to show this canvas is not inactive. It does things. It gives distance. That is also in the movement. What is measuring about? It's a movement. It doesn't happen instantaneously. It takes time. And that is the Lemon-Scriptorian principle. This is the interaction between uncontained, that does the work, takes time, space, the container, and the contained. Three accomplices in what turns into movement of measuring, but also the movement of the electrons and the movement of the uncontained thinking or intention, if you like. All those movements are imperceptible in the Newtonian paradigm. They are hidden under the surface, so to speak. And what Rosen does is to bring those to the forth, so you can see them. In this context, I would say, the Klein bottle, the Möbius strip, and also the Necker cube are essential to get to an understanding that is both experiential, and we also take help of the paradoxes. They show us where to go. Don't go into the paradox. I mentioned a paradox here in the Newtonian physics. It looks very great, but it leads in the end to you have to make a choice, which that is between coherence or consistence. So clearly depicted by Douglas Hofstadter in Gödel, Escher, Bach. You cannot directly see the truth. You cannot see the truth directly, but what you can do is see that what you are grasping as true is an illusion. And this is shown in the book Gödel, Escher, Bach. The paradox is the message. So in a way, directly looking for the truth, the proof, is wrong. You need to go to the paradox first. That paradox will be your master. That will be your sadhu. That's why that's such an excellent book. Maybe we should put a pause here. So we concluded the table here that you can find on page 105. Action cycles of topodimensional life worlds. And I was pointing to that seemed the thrust of Newtonian physics is the evisceration and disappearance of the subject. Here we have an tendency that the subject is necessary. No reality without it. We are participating in reality. We are not one extra substance or emergent out of something that is more foundational. And earlier in the chapter we saw that dialecticity is absent in the Newtonian take. There is not the force between oppositions. That very opposition that makes possible individuality, as we looked at, but also true universality. I thought about Derrida that show that without opposition, words lose their force. they become one-dimensional in the bad sense, obliterated. Rodolphe Gachet called that nullification. It is when a text or someone says disappears by itself, by the dichotomies, by the polarities that are built up in the text. Plus and minus gives null and nothing. And a text built up by only oppositions or partly would be less of a text. But a dialectical text is forceful, have the strength of showing things. I'll continue on page 107, last paragraph. To enhance our understanding of the table, let us begin by considering the idea of the stationary wave. See, now you have stasis and movement in the same word, my comment. Such a wave is formed from the interference of two waves traveling in opposite directions. Figure 5.8 gives the four most basic configurations of stationary waves. These wave patterns can be created in objects such as musical instruments, the waves here are quantized, divided into segments of equal size that are describable only in terms of whole numbers. We would not find a stationary wave with 1.5 segments. For example, Figure 5.8a displays what in music is called the fundamental tone or first harmonic. This baseline frequency corresponds to the state of lowest vibrational energy. Figures 5.8 through 5.8d display the overtones of this ground state. Recall on our chapter 4 discussion of the ether-like microphysical ground state or vacuum. That Bohm characterized as an immense ocean of cosmic energy. If the particles that make up our universe are excitations of this cosmic ground, we might imagine them as overtones of the ground, similar to the way Erwin Schrödinger initially conceived them. But Bohm's writing on this actually implies a subtler, fourfold distinction. First, there is the cosmic background of energy, or oceanic hollow movement, serving as the ground for the existence of everything, including ourselves. From this universal flux, more differentiated forms of movement arise. Such as radio waves or sound waves, which can carry signals or information that in turn can influence the behavior of matter and energy. The fourfold distinction then is among the hollow movement more differentiated forms of movement. The implicit information they carry and the observable effects of this information in the physical world. The topodimensional eigenvalues given in table 5.2 spin matrix correspond to the four primary forms of movement. For now, we will focus on the relationships among these forms. The question of the information that is carried by the dimensional waves will be taken up in chapter 10. The table 5-2 matrix meets the need for something more than the single harmonic series illustrated in figure 5.8. For the overtones of such a series merely constitute higher registers of but one fundamental wave action. Whereas each of the four orders of dimensional action we have been exploring must be seen as a fundamental action in its own right. A dimensional sub-objectivity constituting a unique eigenwave or self-identity. The deeply qualitative differences among the four hypernumber identity operators is consistent with Musset's characterization of different hypernumbers as new forms of unity, which is to say, new kinds of number. For as goes one, the identity operator, so go all numbers. But it seems we should go even further. For while the eigenvalues displayed on the principal diagonal of the matrix surely do not just differ quantitatively, neither do they merely express different qualities of the world. Rather, as distinct spatial sub-objectives, they represent different life worlds. And yet, they are intimately related. What we have in the topodimensional wave matrix is not simply a single ground wave carrying information in the form of overtones, but a hierarchy of interrelated dimensional ground waves or fundamental tones. Take the example of the two principal elements of highest dimensionality, epsilon O2, a two-dimensional Möbius vortex, and epsilon D3, the three-dimensional Kleinian vortex. In the matrix, these elements are linked by the combining elements given in the two corresponding non-principal cells, epsilon D3, epsilon D2, and epsilon through D2 through D3. Sad coupling cells are related to each other enantiomorphically. They are mirror images of one another. We mentioned this term earlier on, enantiomorphically or enantiomorphical, being a mirror image. The coupling cells signify the depth-dimensional counterparts of the conventionally observable, oppositely oriented Möbius strips, which, when glued together, form the Klein bottle. Taken strictly as an eigenvalue, the depth-dimensional Möbius element is the open-closed, one-edged spin structure of the two-dimensional life world. But when we shift our view of the Möbius, consider it in relation to higher Kleinian dimensionality, a kind of doubling takes place in which the singular Möbius spin structure, epsilon D2, becomes a pair of asymmetric mirror opposed twins. Whereas in conventional observation, these are open Möbius surfaces in three-dimensional space. What we now require is the depth dimensional realization of enantiomorphs. Before proceeding, I must acknowledge a limitation of Table 5.2. As we are about to see explicitly, the dimensionalities given in the table, in fact, are involved in developmental processes. Events unfolding over time, the lower dimensional fundamentals carry or support the self-development of the higher dimensional ones. But the table itself gives us only a synchronic view. With all matrix elements being displayed as simply co-present. In chapter 7, the matrix would be set in motion to provide a more dynamic rendition of topodimensional generation. For the preliminary account presently given, we are obliged to read our synchronic table in a diachronic fashion. That is very important. Needs to understand. If the understanding comes in at the wrong moment, it will not be correct. So trying to understand something before will actually stop understanding. There is a movement also in understanding. I would say that's a variety of understanding the uniqueness of the subject. A generalized understanding will nullificate all understanding. The subject is unique. It is not generalized individuality.
1 hour and 40.
When the Klein bottle is taken as an object in ordinary space, it is seen as simply deriving from the fusion of Möbius strip enantiomorphs. The depth dimensional understanding of the Klein bottle suggests that this cannot be the whole truth. in the view of the self-containing, self-transforming quality of the Klein bottle previously intimated. It appears we must regard this fundamental eigenstructure as developing, at least partially, from internal action, from dialectical action upon itself. What then is the underlying role of enantiomorphic action? Let us say that one enantiomorph, epsilon through, functions as a nascent form of the Kleinian wave engaged in dimensional self-generation, while the other, epsilon d3 through epsilon d2, operates in the capacity of a Möbius carrier wave that guides Kleinian autopoiesis. We're going to put a pause and have a summary. So we take the symmetry evolving chart, table 5.2, which is the interrelational matrix of topodimensional spin structures. I don't think I realized today how closely stasis and movement are together. It's very hard to directly from quantum mechanics understand that movement is inherent in stasis. And our view, for instance, as I mentioned earlier on, that we obviously would be able to both have a sort of numerical value of location and momentum at the same time, like these factors were separable in some way. Here I understand that they are not separable, not in that matrix. Actually, their inseparability is what speeds up their differences. Were they separately, they would cause a sort of polarization that would lack the energy to have movement. It's so easy to fall into this trap, and our language is actually not helping. It gives the idea of things being presently out there forever, or at least for a very long time. Some languages, like the Lakota Indian language or the Navajo, challenges that. But our languages in the Western Hemisphere, with their nouns and the ideas of predicate, something to a noun. The red wall, for instance, red is in some way separable from the wall. You can have a wall without color, and then you can have the pure color. And isn't it odd? These are the conclusions already nascent, almost terminated in antiquity. James Locke was absolutely certain that color was an extra thing put on reality. And so was the surface of something, its edginess. And as you have a noun, you obviously want to have a predicate on that noun. Tall man, the short tree, the long beard. So you have the verb, the movement, it's separable, and you can focus on just the noun. And then you can part the noun into its predicate. And this predicate is in classical physics momentum. The electron is separable from the momentum. Separatedness is what we breathe. This is the first thought you have in the morning is of separation. And the last that brings to your mind when you fall to sleep is separation. We all know when sleep comes, separation slowly dissipates. And we go into the dream states. That is the superposition state, quite literally. Two things that are contradictory in the dream state are quite possible. Contradictory in the wakened state are quite possible in the dream state. And this idea of a separable object leads to these debates, for instance, the one we had with a cat of Schrödinger. It is impossible to understand regarding how our language and our grammar functions to say that the cat is alive and dead at the same time. But it's so easy to say in Navajo. So compared to learning Navajo, this is actually quite easy. You can think about it that way. But I would say this is a unique key that opens the lock of quantum physics. This is the first step into allowing both things at the same time. And not giving away the individuality of the two poles either. Rather enforcing them. Which I think is Kalle's question. I don't know. Let's put it out there.
I already asked you that it was about the role of eigenvalues in quantum physics, and you have helpfully written it out so I can actually read your answer. Quantum mechanics shows uniqueness.
The Newtonian paradigm.
Yes, of course. The Newtonian paradigm only there are only generalities. Only generalities exist. Eigenvalue is the uniqueness. Indeed. So it's very good. So I like the word eigenvalue, and it reminds me of a word that Derrida liked. Let me take this pen. I used this. I think also in Heidegger you find this adjective eigen, but I am familiar with the discussion in Derrida. He uses the French word propre. That is the French translation of eigen, that is own, but in French you have different ambiguities, and Derrida plays with these ambiguities. Let me see, do you see propre? So in French, it can mean both own, like in German, propre, but it can also mean clean. And Derrida plays puns on these two meanings. And you have this like in property, like property and things that you own. So he plays with these words. I don't remember his so to say, what was his point specifically, but one could be that there are no clean meanings, so to say, in words. So you cannot say, if you apply to this, that this is only surface. Everything has levels, so to say, already embedded. So propre can mean both clean and own, and eigen, I suppose, would also mean not only own, but what else could it be in general? I don't know, but everything is. And so he did in his own way. He comes to the uniqueness through ambiguities. So, do you want to add something, Hans?
Yes, how true. And it took me a while to get to Stephen M. Rosen and this understanding. I struggled for a long time with Arkady Plotnitsky, and yes, I think he is marvelous, but for me to understand what, because getting out of the grip of language, Arkady Plotnitsky is helpful, but it needed something more even. I'm very good with this propre. Jacques Derrida is one of those people who understood that the dual nature is what's needed. That's the force. Without dialectics, there is no energy between the opposing sides. It is just juxtaposition. The word that Rosen uses in this chapter is to put one at one side. And this is actually pretty close to what Jacques Derrida called the supplément, the additive, adding something to something that is already whole, with the intention of making it wholer. And the best example is there, of course, a definition of something that is absolutely clear in itself. Put a definition on it, you make that supplément parasitic. That's a very good trope for the Newtonian paradigm. In some ways, an extra add-on, adding momentum to a thing that already has momentum. And I'm afraid even our language, when we say a red horse, does it really make any sense other in a very, very particular context when you want to discern two horses? This we have from Ludwig Wittgenstein. In the wrong moment, specification or add-ons destroys understanding, makes it impossible to understand. We currently have this problem in Sweden, where chanterelles have been given the property as a sort of mushroom. Chanterelles that are inherently, listen carefully now, they are inherently yellow. It's part of being a chanterelle to be yellow, and you cannot say yellow chanterelles. It doesn't make any sense. But that is coming from our language, an inherent built-in tendency. It's a tendency, Logocentrism is a tendency. It is not out there. You don't have to fall for it, but it's very, very likely that you will. And a takeaway for me in this lecture is absolute uniqueness of the subject and object. It's only possible with a quantum physical understanding. Even the ego, what we are, has become generalized. We have no sense of individuality anymore. How could we? The Newtonian paradigm, paired with the tendencies in our language, has made that we put a soul where there already inhabits a soul. And we put a free will where free will creates the world. It's already inherent in the objects and everything. And I would say the same comes to God. God is already there. Putting him there as an extra, sort of proving his existence, is saying yellow chanterelles. It sounds absolutely horrific to my ears. But I know now where it stems from. It stems from our language. I say thank you very much for your patience and have a very pleasant morning. Bye-bye.
Thank you.